So we gotta graph this thing. And we're pretty good with if it had said y equals sine x, we would be fine. It's x equals sine y, it just sort of flips everything around. So I'm gonna plug some stuff in for y. If I plug in a 0 for y, I get sine of 0, 0. If I plug in a pi halves for y, I get that the sine of pi halves is a 1. And if I plug in, pi halves for the y. If I plug in pi halves for y, I get a 1 for the x. And if I plug in pi for the y, the sine of pi is 0. So your guy is basically kind of inverted and it kind of loops up this way. But that's one chunk of it, and all we need is from pi fourths to 3 pi fourths. So this chunk is what we're looking for. And we kind of had a hint that it was going to be a right minus left sort of deal because our functions were solved for x in the beginning, which is odd. And so this guy is on the right of the axis, so basically it's just the integral of the right function minus the left function, which is just the x-axis, x equals 0. And we're going, because this is in y's, our limits are in y's, so we're going from pi fourths to 3 pi fourths. And we're good to go, because we can take the antiderivative now. That's our setup for the area. Now all we have to do is evaluate it. The antiderivative of sine is negative cosine. Just got to know those derivatives forward and backwards. And we're going to evaluate it by plugging in the negative 3 pi fourths. So the cosine of 3 pi fourths is negative root 2 over 2. And then I'm going to subtract what I get when I plug in the bottom. Now I'm subtracting a negative, so it's going to be a positive. And the cosine of pi fourths is root 2 over 2. So I'm going to have root 2 over 2 plus another root 2 over 2. So I have 2 root 2 over 2. So I have root 2. Does it agree? It agrees. Heck yeah. Awesome.
Cool.